In this question, it is given that let S be the set of all alpha beta where alpha and beta lie between pi and 2 pi, for which the complex number this is purely imaginary and the complex number this is purely real. Let us define z alpha beta as equal to sine 2 alpha plus I cos 2 beta, where alpha and beta belong to the set S as defined above. You have to find the sum of I z alpha beta plus 1 upon I z bar alpha beta, where alpha and beta both belong to the set S. Note that here you have to take all possible values of alpha and beta and use them here and finally add those values. First of all, let us find the value of alpha and beta. To find the value of alpha, I'll find the real part of it and put it equal to 0 because it is given that this is purely imaginary. To simplify this, I proceed as 1 minus I sin alpha upon 1 plus 2 I sin alpha. To simplify it, I multiply divide by conjugate 1 minus 2i sin alpha upon 1 minus 2i sin alpha. This is equal to 1 minus 2 sin square alpha plus I get now as minus 3 sin alpha upon 1 plus 4 sin square alpha. And now I put the real part of it equal 0. I get 1 minus 2 sin square alpha upon 1 plus 4 equal 0. I get cos 2 alpha equal 0 because 1 minus 2 sin square alpha is cos 2 alpha. And 2 alpha is equal to 2n plus 1 pi by 2. That is alpha is 2n plus 1 into pi by 4. And where n is any integer, but only that value of n will be taken for which the value of alpha lies in the interval pi to 2 pi. Clearly, for n equal to 2 and 3, the value of alpha will lie in the interval pi to pi by 4. For n equal to, I get the answer 5 pi by 4. For n equal to 3, I get the answer 7 pi by 4. Hence, the possible values of alpha are these two. And next step is to find the imaginary part of it. And for finding the imaginary part of it, it's not required to simplify this again as I had simplified this here. Actually, in examination, every second is very important. It is very clear from these two that the difference between these two is wherever there is I, here it is minus I, and wherever it is sin alpha, here it is cos beta. And it clearly means if I had simplified this and got it, after simplifying this, here I will be getting 3 cos beta. Agreed? You can solve it, but because every second is very important, therefore imaginary part is going to be 3 cos beta and I will put it equal 0, and putting cos beta equal 0, I get beta equal to 2m plus 1 into pi by 2, where m is any integer but I will be taking only that value of m, so that the value of this lies in the interval pi to 2 pi. Clearly, for m equal to 1, I will get the value of beta as 3 pi over 2, and it lies in the interval pi to 2 pi. Hence, all possible values of alpha are 5 pi by 4 and 7 pi by 4, and all possible values of beta are 3 pi by 2. And because S is a set of all the ordered pairs alpha beta, hence S will become 5 pi by 4, comma 3 pi by 2 and 7 pi by 4, comma 3 pi by 2, because first place is to be filled by all possible values of alpha, second place is to be filled by all possible values of beta. Had beta got two values, then there will be 4 ordered pairs. Hence, using this, all possible values of z alpha beta will become sine 5 pi by 2 plus I cos 3 pi, and second possible value of z alpha beta will be sine 7 pi by 2 plus I cos 3 pi, and this is equal to 1 minus I, and this is minus 1 minus I. Hence, becomes equal to I into 1 minus I plus minus 1 minus I plus 1 upon I into 1 plus I plus 1 upon I into 1 upon minus 1 plus I. That is I into minus 2I plus minus I into 1 upon 1 plus I plus 1 upon this is equal to 2 plus minus I into minus 1 plus I plus upon minus 1 minus 1. That is 2 minus I into 2I upon minus 2. That is 2 minus 1 equal to 1. In this question, it is given that let O be the origin and A be the point Z1 equal to 1 plus 2I. If B is the point Z2 such that real part of Z2 is less than 0. If B is the point Z2 and real part of Z2 is less than 0, such that OAB is a right angled isosceles triangle with OB as its hypotenuse, then which of the following is not true? According to question, the figure formed is this is the point A having fx z1 equal to 1 plus 2I, and OAB is a right angled isosceles triangle with OB as hypotenuse. Real part of Z2 is less than 0. Because OB I want is hypotenuse, it means right angle must be at A. If right angle is at A, then it is sure that B must be somewhere here, because if B goes here, then real part of Z2 will become positive. For this case only possible that real part of Z2 is negative. And it is given that this triangle is isosceles also. Suppose this is the point B. Once the fx of B is found, the choices can be checked very easily. As it is given that fx of B is Z2, and because this angle is sure to be 45 degree because it is a right angled isosceles triangle. Hence, using the Coni's formula, or you can also say as rotation formula, I can say that OB is equal to OA into cos pi by 4 plus I sine into final length upon initial length is root 2. Therefore, root 2 will come. Here angle is positive because from OA to OB the direction is anti-clockwise. And now Z2 minus 0 is equal to Z1 minus 0 into 1 by root 2 plus I into 1 by root 2 into root 2. Z2 equal to Z1 into 1 plus I. That is Z2 equal to, because Z1 is given to you as 1 plus 2I, hence it is 1 plus 2I into 1 plus I, that is 1 minus 2 plus I into 3. That is the answer is minus 1 plus 3I. Note that the examiner has written ARGZ. That is, he has clearly written small a, and small a means he is telling us to find the principal argument. If he says, this will mean that he wants the general argument, and small a means he wants the principal argument. And we know that formula is argument of a plus b is tan inverse b by a if a is positive, and tan inverse b by a plus minus pi if a is negative. If you don't know, remember this formula. Plus pi will be used if b is positive, minus pi will be used if b is negative. You have to remember this formula. Here it is clear that a is negative, b is positive. Hence, keeping that formula in mind, argument of minus 1 plus 3i becomes tan inverse 3 upon minus 1 plus pi, because b is positive here. That is, I get pi minus tan inverse 3. Hence, the information in choice A is correct. The information of choice C can be checked very easily. It is clear that modulus of this complex number is root 10. Hence, I can say information of choice C is also correct. Now we have to find the value of argument of Z1 minus 2Z2. That is argument of 1 plus 2i minus 1 plus 3i. That is argument of 2 minus I. And as I told you, argument of a plus bi is this if a is positive, this plus minus pi if a is negative, plus pi is used if b is positive, minus pi is used if b is negative. That is equal to argument of 1 plus 2i minus 2 into minus 1 plus 3i. That is argument of 3 minus 4i. And just now I told you, recall that when he has written small a, it automatically means he wants principal argument, and it is tan inverse b by a is if a is positive, and here a is positive, therefore I get the answer tan inverse minus 4 by 3, that is minus. Hence information of choice B is also correct. And to check the choice C, 2z1 minus z2 means 2 into 1 plus 2i minus 3 plus I, which is equal to under root 9 plus 1 equal to root 10. Hence I can say the information of choice D is wrong, and because he wants the choice which is not true, because this information is wrong, hence D becomes the correct choice. In this question he is saying if z equal to x plus yi satisfies the condition mod z minus 2 equal to 0, and also it is given that mod of z minus I minus mod of z plus 5i is equal to 0, you have to find the correct choice. This information means mod z equal to 2, that is mod of z minus 0 plus 0 iota is equal to 2. Clearly this represents a circle with a fix of center as 0 0 and radius 2, and this information means mod of z minus I is equal to mod of z minus 5i. That is I can say z is a complex number whose distance from iota and minus 5 iota are equal. That is, if iota is here, minus 5 iota is here, midpoint will be at minus 2 iota for any point on this line. This line is perpendicular bisector of the line joining A and B. For any point on this line, say P, this will be surely equal to this, and I want those complex numbers whose distance from iota and minus 5 iota are equal. It means for this condition to be true, Z will have to move on this line. And this was the equation of a circle with center 0 0 and radius 2. And radius 2 was there. Hence, this is a complex number which lies on this line also and lies on this circle also. Therefore, there is only one complex number minus 2i which will satisfy this condition and this condition both. And now z equal to minus 2 iota means x equal to 0 and y equal to minus 2. And let us see this value of x and y satisfies which condition. Clearly this doesn't satisfy this doesn't satisfy this also, This satisfies this. Hence, C becomes the correct choice. Otherwise, D also can be checked very easily. It doesn't satisfy D also. Hence, I can say C is the correct choice. In this question, he is saying if Z is a complex number and if the minimum value of this is 5 root 2, then the value of P is. Clearly, this represents the distance of Z from 3 root 2. This represents the distance of Z from the point 0, P root 2. That is on y-axis. And minimum distance between them is 5 root 2. Clearly, the point having complex number 3 root 2 will lie somewhere here, complex number 3 root 2. The point having complex number p root 2I will be somewhere on y-axis having coordinate p root 2. Let z be fx of the point C, and clearly this will represent the distance AC. This will represent the distance CB. Therefore, the value of this will be AC plus BC, and minimum value of this is given to you as 5 root 2. AC plus BC minimum, clearly AC plus BC will be minimum when C will lie somewhere on AB. That is, I can say AC plus BC has the minimum value AB, and this will be there when C lies somewhere on the line segment AB, and the minimum length is given to you as 5 root 2. This is 3 root 2, this is 5 root 2, this is P root 2. Hence, I can say P root 2 square plus 3 root 2 square equal to 5 root 2 square. That is P square plus 3 square equal to 5 square. That is P square equal to 4 square. That is the value of P is 4 or minus 4. Hence, out of these choices, C becomes the correct choice. In this question, it is given that let Z1 and Z2 be two complex numbers such that Z1 bar is equal to I Z2 bar. Then argument of Z1 upon Z2 bar and argument of Z1 upon Z2 bar is pi. Then you have to find the correct choice. To find the correct choice, let argument of Z1 equal to alpha and argument of Z2 equal to beta. With the help of given information, I will find two relations between alpha and beta, and from those two relations I will find the value of alpha and beta. This information implies that argument of Z1 bar is equal to argument of I Z2 bar, and we know that argument of Z1 bar is minus of argument of Z1 bar. Therefore, this becomes minus alpha equal to argument of I plus argument of minus Z2 bar, that is pi by 2 minus beta, that is beta minus alpha is pi by 2, and this means argument of Z1 minus argument of Z2 bar, that is alpha minus beta is pi, that is alpha plus beta is pi, and beta minus alpha equal to pi by 2, alpha plus beta equal to pi, implies that beta equal to 3 pi by 4. Hence alpha becomes minus pi by 4. Hence I can say C is the correct choice. In this question it is given that if the four complex numbers z, z bar minus 2 times real part of z bar and fourth z minus 2 times real part of z represent the vertices of a sphere of side 4 unit in orthogonal plane, then mod z is equal to, let z equal to a plus bi. Clearly z bar will become a minus bi and z bar minus 2 times real part of z bar will be a minus bi minus 2a, that is minus a minus bi, and similarly this will become minus a plus bi. Obviously these points will be mirror image of each other in x axis and y axis. For example, if a plus bi lies here, then a minus bi will be somewhere here. It will be minus a plus bi, and here it will be minus a minus bi. And because it is given that the figure formed by the vertices is a square, it means this rectangle is a square. That is, I can say this is a and this is b. And because length of each side of the square is 4, hence I can say this is 2 and this is also 2. A is 2 and b is 2. Hence mod z will become 2 root 2. That is, C becomes the correct choice. In this question it is given that let z1 and z2 be any two non-zero complex numbers such that 3 times mod z1 is equal to 4 times mod z2. If z equal to 3z1 upon 2z2 plus 2z2 upon 3z1, then you have to find the correct choice. This information can be written as mod of z1 upon z2 equal to 4 by 3. Let argument of z1 upon z2 be theta. It means z1 upon z2 can be written as 3 by 4 e power I theta. Hence, using this, z becomes 3 by 2 into 3 by 4 e power I theta plus 2 by 3 into 4 by 3 e power minus I theta, because z2 upon z1 is written. That is, it becomes 9 by 8 e power I theta plus 8 by 9 e power minus I theta. It can be written as 9 by 8 e power minus I theta into 81 by 64 e power 2 I theta plus 1. It is the value of z. Clearly, first choice is wrong, because clearly as theta varies, the value of this varies. Real part of z equal 0 will mean this is purely imaginary. Clearly, the real part is 9 by 8 cos theta plus 8 by 9 cos theta, which is non-zero, which can be anything. Hence, first choice becomes wrong. mod z equal to root 5 by 2. It is also wrong because if I take mod z equal to 9 by 8, the mod of this is 1, mod of 81 by 64 e to power 2i theta plus 1. Clearly writing e to power 2i theta as cos 2 theta plus I sin 2 theta. This is a variable quantity, hence B is also wrong. Similarly, C is also wrong because mod z being a variable quantity is not fixed. D is also wrong because the imaginary part of this will be 9 by 8 sin theta minus 8 by 9 sin theta, that is which can be 0 also and non-zero also. Hence, it is not necessary that imaginary part of z is 0. Therefore, actually this is a wrong question. Hence, bonus marks must have been given at that time.